A while back I got the bright idea to ask my viewers for questions that they had about spaceflight. I got 252 top-level comments, which is both an opportunity and a problem. How would I deal with so many questions? The first step was to get them out of YouTube. Nicely, and perhaps surprisingly, YouTube provides a really nice .NET interface. I opened up Visual Studio, created a C# project, and wrote myself a YouTube comment extractor that would pull out all the top-level questions and write them to a CSV file that I could import into Excel. Then, after about 10 minutes of looking at that file, I did two things. The first was that I broke it into Starship and non-Starship questions, and then I took out the CSV backend and put in a PowerPoint backend, so it would walk through the questions and then create a PowerPoint slide for each question. But even with that automation, I can't answer all the questions, which makes me feel a little bit bad. So I came up with an alternative. I created a subreddit on Reddit named, not surprisingly, EagerSpace. I will post video links there, at least when I remember, as I currently do on Twix. But the real point is that I'm more likely to answer questions there because it's cheap, and I'm there quite a bit anyway, and other people can answer questions as well. On to the questions. There were 4 really good questions about nuclear thermal rockets. Do you think that a widespread adoption of nuclear rocket engines will come after the Draco program? Do you think we'll see a viable nuclear rocket engine tested in the first few decades, potentially in space or the moon or Mars? My weaselly answer to these questions is that it will depend on what they actually end up building. But that's not very satisfying, so I'll see what I can do. If you've watched some of my other videos, you know that I call myself a skeptic when it comes to nuclear thermal rockets. If you haven't watched them, you should go do that now. And I should probably enumerate why I'm skeptical. First, as far as I can tell, nobody is self-funding development of NTRs, which generally means companies are more excited about the development dollars than they are about the commercial or military applications. Second, I can read the rocket equation and do simple calculations. Pretty much universally, the nuclear rocket advocates talk about how great the specific impulse is and totally ignore the mass ratio. I complain about this a lot when it comes to hydrolox engines, but it's a lot worse with NTR because the propellant is only liquid hydrogen, so the tanks are giant, and the engines made out of very heavy uranium are not surprisingly very heavy. Third, everybody ignores all the other problems. The core is hugely radioactive once you turn it on, which means nobody wants to be around it. You want to run it hot to get the highest specific impulse, but that means you might melt your core, and you can't actually turn it off when you want to, because you have to keep running hydrogen through the core to slowly cool it off. And your engine is low thrust. You basically get RL-10 level thrust out of most designs. Fourth, NASA cheats whenever they make mission-based proposals. They come up with these gossamer tank designs that weigh nothing but somehow are good enough to hold in liquid hydrogen, and they compare them to standard designs. The problem is that there isn't enough reality. Which brings us to the Draco program, which as far as I can tell is a continuation of the NASA program, but is now run by DARPA. And not surprisingly, given the way NASA is running things these days, there's been no status update on the program since it was first started. I'm on record saying that I support the NASA program because I just want someone to build and fly something so we can have a real stage that I can talk about, rather than basing my opinion on a bunch of less trustworthy sources. That's not a very exciting opinion, so I will make 3 predictions. The first is that Draco will fly a real stage and test it in orbit, though it won't be in 2027. I'm really going out on a limb here predicting that a space program will be late. The second is that Draco will be unimpressive. It's not going to make anybody want to use it instead of a chemical engine. I'm predicting this because the parameters set up in the original NASA proposal pretty much assured that the resulting engines will be boring. I'd love to be wrong here and see somebody step up with the advanced technology that advocates have talked about for so long, but there are good reasons that we probably won't see that. The third is that advocates will use the results as a talking point to assert that Draco shows the concept as promise, and it just needs a lot more money to reach its goals. Add in a bonus prediction. Somebody is going to go crazy about the prospect of flying a nuclear engine. There are lawsuits over simple RTGs, and this will be a full reactor. In your opinion, Is it really worth the development costs of nuclear thermal, nuclear electric propulsion in order to build the next Mars transfer vehicle, as many of NASA's current Mars plans generally outline? Or is chemical the way to go? I already talked about nuclear thermal, so this will be about nuclear electric. Conceptually, it's pretty nice. You use a nuclear reactor to generate a bunch of electricity, and then use that to drive a system based on ion thrusters. You need a whole bunch of ion thrusters to get a useful level of thrust, but that appears to be possible, and they have crazy high specific impulses, which means they are very fuel efficient. The problem is heat. We generally think of space as a very cold place, but it's really a place where the usual methods of heating and cooling do not work well. No convection or conduction, so we are stuck with radiation. The International Space Station has these large radiators to get rid of waste heat. The problem with nuclear electric is that nuclear reactors generate a ton of waste heat. The efficiency of your radiators depends on how hot they are. If you want to use water-based radiators, you are going to need a ton of them, like in this NASA design. The alternative is to use a much hotter fluid, with liquid sodium being a common choice. This has been used in fast nuclear reactors, but they use a very special design. Sodium will be much hotter, and therefore give you smaller and lighter radiators, with the slight downside that if your system springs a leak in any place with air, it will immediately catch fire. And if the system gets just a little too cold, the sodium solidifies in the pipes. The concepts after that get even weirder, including liquid droplet radiators, where you spray the hot fluid in a stream and then collect it after it is cooled. As usual, Winchell Chung's Atomic Rocket Sites has all the best information on radiators. So my summary is that the nuclear electric heat problem seems like a really hard one to solve, and for the inner solar system, solar electric is probably a better choice. Nuclear thermal rocket afterburners compared to regular nuclear thermal and regular chemical. And then there's a link to a paper. In short, compared to normal NTR, ISP goes down, thrust goes up, tank sizes go down, and you can use the oxygen you get from ISRU resources. That's a fun paper from 1994. The concept is normally known as Lander, for LOX Augmented Nuclear Thermal Rocket. You take a normal nuclear thermal rocket, and then when you need extra thrust, you inject LOX into the nozzle, and it functions as an afterburner. It's a multi-mode rocket, low thrust and high specific impulse with pure hydrogen, high thrust with lower specific impulse with oxygen, or somewhere in between. The big issue I see, beyond the usual NTR disadvantages, is that with a lot of oxygen, the specific impulse is down to only about 500, and you have an engine that weighs about 7 times what an RL-10 Hydrolox engine weighs, but gives equivalent thrust, which means you get a worse mass ratio, and therefore less delta V. I don't see much benefit over a Hydrolox engine. What is your education and professional background? Can you give us a high-level view of your background? I suspect you worked in the industry. When I was 5 years old, I wanted to be an astronaut. By the time I was 12, I switched to engineer, which was more practical, especially given my eyesight. Then I went to high school in 1978 and had a math teacher who was ahead of his time and got exposed to an Alpha Microsystems computer with ADM3A terminals, and the die was cast. Programming was both easy and fun, and it was pretty clear that I was going to make it a career. I have a BS in computer science with minors in math and business. I worked at a number of different places during my career, including a long stint at a major Redmond software company. So the obvious question is, how do you know all this space stuff? The first explanation is simply time. If you're interested in a topic and you study it for 4 decades, you tend to accumulate a lot of useful information. Or at least I do. The second explanation is that I'm a generalist. I do have in-depth knowledge in some areas, but I have a decent level of knowledge in a bunch of areas. For this channel, I know a fair bit of physics, chemistry, engineering, material science, business, organizationology, not sure what I should call that, and psychology. That gives me the ability to see connections, which is good. It also means I run out of depth in a lot of areas. I know a little about rocket engine design, but nothing compared to the people who do it for a living. There's another old word that kind of applies, and that's polymath, in the sense that I have wide-ranging interests, and I know a lot about a bunch of topics, like I know what a polymath is. If we look at the polymath scale, I'm down here, a long way from the greats like Da Vinci, Franklin, and Martin. If given the option to fly to space on any vehicle, historic, current, or near future, which would you pick and why? There can only be one choice. I think it's both the safest and the coolest. What is the real reason for retirement of Space Shuttle? If you watch my video about how SpaceX might have failed, I talk about it there. The short answer is that President George W. Bush wanted a legacy, and he chose a really cool space program. And that required canceling Shuttle because there wasn't enough money to do Shuttle, the space station, and the big exploration program. Turns out there wasn't enough money after Shuttle was canceled, but that's another story. Will you bring back the old EagerSpace intro? Unlikely. It was funky and different, and probably the worst thing I did in terms of getting subscribers to the channel. But take a look at the end of this video and tell me if you think it works as an outro. Do you think SABRE Skylon will eventually become a thing? Do you think the Skylon spaceplane or even just the SABRE engine will have any hope at this point? Unlikely. SABRE is a concept for a hybrid mode rocket engine where you take in outside air, cool it down a bunch using a heat exchanger, and then that cooled air is injected into the rocket engine and burned with liquid hydrogen. The concept has been around in various forms since the 1950s. The reason I think it's unlikely is that A, they were initially talking about a single-stage to orbit vehicle, and that made very little sense, and B, nobody really wants to put money into it. That second one is usually a good indication of problems with a concept, as companies have to disclose a lot of information to get funding. Note that the opposite is not true. People putting money into a project is not a sign that it's a good bet. I also found it strange that Reaction Engines was targeting SABRE towards single stage to orbit, when that is so obviously a really hard thing to do. It would make more sense to target it towards hypersonic flight, where the constraints are easier, and you may garner interest and money from the military. If you go to the Reaction Engine website, you can find information about SABRE if you dig deeply enough, but their tagline is now thermal management for a cooler, cleaner world. Is there a chance for China landing first on the moon? Probably not, but if you're asking whether the Chinese will beat Artemis to the moon, I think it's pretty likely. One of the reasons that Apollo succeeded was that the program was deeply tied to American pride. The Chinese are very proud of their space program and have, from what I can tell, a decent moon program. Artemis is this weird program that came about because Congress told NASA to build a big rocket and work on a capsule, and ended up spending $45 billion on it, and it seemed like going back to the moon was something you could do with it. That's why we're in this weird situation where Orion can get to lunar orbit, but there's no NASA-developed lander, and the architecture to use Starship and Blue Moon as a lander is so weird. Will we see a permanently occupied moon base in 10 years? Is it economically viable? NASA, of course, has wanted this for years, and DARPA is working on their Luna 10 architecture. For anything like this to happen, we need a combination of two things. The first is cheap enough transport for people and cargo to the lunar surface. I'm not sure what cheap enough actually means, but Starship might get you there, and the Blue Origin Mark II lander might get you there as well. The second requirement is for there to be somebody who cares and can pay for it. And that pretty much has to be Congress. NASA cares, but they don't control their budget, and DoD cares, but they would also need congressional approval. I'm kind of thinking the answer to the question is no, but it's going to depend on how Congress reacts to China getting there, and how cheap transport ends up. As for economy, there's a lot of talk about a cislunar economy, but nobody has a real application where it would make sense, and by that I mean a market that somebody will actually pay money for. Do you think a rotating detonation engine will ever replace a traditional upper stage engine? Do you think rotating detonation engines will ever be useful, or are they a bit delusional, like nuclear thermal engines? Rotating detonation engines have been getting a lot of hype. A video on them is on my list, but I'm only interested if I can answer these questions, and I don't think there's enough data yet. Is it a real innovation, or is it another aerospike? I simply don't know. I tend towards skepticism, but I could be wrong. Where's that HLS propellant analysis you promised in the orbital depot video? I suspect the answer you are hoping for is in the works, and I'm afraid I'm going to have to disappoint you. When I released the propellant depot video, I was already at work on 2 other videos, and those took priority for a few weeks. Then I came back to look at the HLS video, and I ran into some immediate issues. The depot analysis was pretty simple to do, and I could come up with reasonable approximations. It's a big round tube of metal, and the factors are reflected sunlight, infrared from the Earth, and direct sunlight. The HLS Lander is a lot different. It's a big round tube of metal modified in unspecified ways. It's partially full of fuel. It has solar cells on some unspecified part of it. It needs to keep the crew section warm. And it's landing in different areas of the moon with different incident angles of sunlight. One problem at the time was we only had one render of what the lander would look like without much detail, and SpaceX was, and still is, quite tight-lipped about what the lander will actually look like. The second problem is the last one listed. The lander will get heated by the sun, presumably coming from the side because it's landing near the South Pole, and it will be heated by sunlight reflected from the moon's surface, and also by infrared coming off the surface. There were things there that I didn't know how to model that differ depending on where the landing site is and when the landing occurs, and I suspected that the things I didn't know would have a big impact on the result. So at the time I decided I wasn't really up to it. And in the last month or so, I had a discussion with somebody who knows way more than I do, and based on the approach they said they would take, I'm more sure that I'm not up to it. This was a single comment, but there are two distinct questions. Is there a reason satellites and landers have stopped being made with RTGs and instead only use solar panels? RTG means radioisotope thermoelectric generator, a way of using the heat from decaying radioactive materials to make electricity. There are two big factors. The first is that RTGs are a big pain in the butt to deal with from a legal standpoint. This paper says the following. The launch approval review for spacecraft with radioisotope thermoelectric generators is a lengthy, multi-year, and multi-million-dollar process. Even after that process, you will very likely get sued and have to deal with that. There's also both national and institutional policy that says radioactive solutions can only be used when they are a big win. NASA, of course, has a study from 2019 that compares missions that use radioactive or solar power sources. This graph shows the mass of the electrical power system compared to the mass of the whole spacecraft bus, mass without payload. The nuclear, or RPS, missions are coded in blue. I mostly expected the solar ones to be heavier because solar panels are heavy, but the radioactive elements used are also very heavy, and they tend to have heavier spacecraft buses. That probably has an effect on launch cost, or the mass of the payload you can fly. The second graph looks at the cost of the electrical power system, and it turns out the nuclear systems are considerably more pricey. Or, to put it another way, you spend more of your budget on power than if you use solar. Solar is a pretty obvious choice for inner solar system missions, but I was surprised to find this result from the Europa Clipper mission all the way out to Jupiter, where solar won pretty resoundingly. I do expect that missions to Saturn and beyond will still rely on radioactive power sources, because the sun is so dim at those distances. Do you think that Solar+Batteries is reliable enough for moon settlement and manned exploration on Mars? For Mars, you can get away with solar panels and batteries. The lunar night is 14 days long, so you will need a lot of batteries to make solar work. In either case, I think you'll be a lot happier if you have a few kilopower reactors to give you a constant power source. What is your favorite book? I read a lot, so this is a really hard question to answer. In the non-fiction space realm, I recommend Escaping Gravity by Lori Garver, which is a great look inside NASA during commercial crew. Liftoff by Eric Berger, which looks at SpaceX during the Falcon 1 era. I'm going to pre-recommend Reentry, which is Eric Berger's book about Falcon 9, scheduled to release in September of 2024. Everybody should read Rand Simberg's Safe is Not an Option. It's very insightful, and the Kindle version is only $5. And finally, Apollo Remastered by Andy Saunders is just a stunningly great photography book about Apollo. If you've ever wondered what a talented photographer could do with the Apollo originals, this is the book for you. It's not cheap, but you really want the hardback. I'll also recommend the classic, Surely You're Joking, Mr. Feynman, and the sequel is pretty good. James Burke's Connections is also a classic, along with The Day the Universe Changed. For science fiction, I have 3 series to recommend. Trading in Danger by Elizabeth Moon, Valor's Choice by Tanya Huff, and Live Free or Die by John Ringo. But that didn't really answer the question. My favorite book is Pride and Prejudice by Jane Austen. If you prefer to watch a video, by far the best version is the 1995 BBC miniseries starring Colin Firth and Jennifer Ely. Would you consider doing a super speculative video on fusion-powered rockets? Both atmospheric and space propulsion would be interesting. I might. I've heard that this playlist is okay. Can you give us a glimpse or a bullet point synopsis of how your list of planned videos, both subject and planned release order, changes from before you posted this video to after you finish analyzing the requests? Happy to share my process, which I think should make the answer clear. This is my main topic board. I haven't looked at it for a while, and there are a few that should no longer be there. The tear in the paper is because of my cats jumping onto the top of the door and then tearing things off as they slide down. That leads to the overflow of topics on my workbench, which are post-its that my cats knocked down or fell off on their own. And then finally, what is closest to my current backlog is another set of post-its on top of my deck, though the main pile was actually hiding under some envelopes. The SpaceX 1990 and Lunatin DARPA topics are new ones that came out of the viewer questions. The drone ship landing video came out of the questions as well, and there are a couple more questions that might make their way to a separate video. I'm not sure yet. I'm generally working on one video at a time, with maybe a second one in introductory stages when I get tired of the first one. While I'm finishing this one, I'm working on a new one about the future of NASA, and working on another one based on questions. All that is a short way of saying that my process is very ad hoc, and therefore I can't answer the question. I'd like to hear about the various types of rocket engines, like gas generator, or whatever it is that Raptor does. No way can I equal Tim Dodd's video, Rocket Engine Cycles, How Do You Power a Rocket Engine? Go watch that. What do you think about Neutron from Rocket Lab? This video is a little dated, but I mostly still agree with what I said here. Are we done with questions? Yes. Yes, we are. If you enjoyed this video, I could really do with a cold beverage. I can't drink the real stuff very often because I'm kind of allergic to alcohol, but this is a decent substitute. EagerSpace. Teller's Tachyon Tablets is a proud sponsor of EagerSpace. Worn out after a long day of asteroid mining? Frazzled by FTL fatigue? Step up today to Teller's Tachyon Tablets, the premium hyperspatial restorative.